You think you understand the speed of light, you learned it in school. Nothing can go faster than 299,792,458 meters per second. It's the universe's speed limit. End of story. Okay, tell me why. Why can't anything go faster? What happens when you try? Do you slam into some invisible wall? Does the universe reach out and grab you and say no? Most people say something like, it takes infinite energy. But that's not an explanation. That's just describing the symptom while ignoring the disease. Here's what Einstein actually discovered. And it's not a speed limit. He discovered that speed itself stops making sense. That time and space twist and deform as you accelerate. That from your perspective inside the ship, you could cross the entire observable universe in the time it takes to drink a cup of coffee. The speed of light isn't a wall you can't break through. It's a revelation that the wall was never there, and neither was the road you thought you were traveling on. Let me show you what I mean. The standard explanation goes like this. As you approach light speed, your mass increases, so it takes more energy to accelerate, and at light speed, you'd need infinite energy. Done. Move on. That explanation isn't wrong exactly, but it's backwards. It's like saying you can't walk to the North Pole because it gets colder. The cold isn't the reason. The cold is a symptom of something deeper about where you are on the planet. Same thing here. The infinite energy isn't the reason you can't reach light speed. It's a symptom, a side effect of something far stranger happening to the fabric of reality itself. Einstein didn't discover a speed limit. He discovered that space and time are not what you think they are. He discovered that motion doesn't just move you through space. It trades space for time. And that trade has a fixed exchange rate. The speed of light is that exchange rate. Once you see that, the entire question flips. You stop asking, why can't I go faster, and start asking, what is speed really? And the answer to that question will permanently change the way you understand reality. Start with something simple, something you already know but have never thought about. Imagine you're driving on a highway. You're going 100 kilometers per hour. The car next to you is going 100 kilometers per hour. You look at each other, relative to each other, you're not moving at all. Now that car speeds up to 150. From your perspective, it pulls away at 50 kilometers per hour. Simple subtraction. This is so obvious it feels stupid to even say. This is called Galilean relativity. It's how you intuitively understand motion. Speeds add and subtract. If you're in a train going 100 and you throw a ball forward at 50, someone on the ground sees the ball going 150. Clean. Logical. Now do that with light. You are in a spaceship going 200,000 kilometers per second, 2/3 the speed of light. You turn on your headlights, the light leaves your ship at 2,092,458 meters per second. So someone standing still should see that light traveling at the speed of light plus your speed, right? That's how it works for everything else. Speeds add, except they don't. The person standing still measures your headlight beam at exactly 299,792,458 meters per second. Not faster, not your speed plus light speed, just light speed, exactly. You're moving at 2/3 the speed of light, and the beam is still pulling away from you at the full speed of light. And the person standing still also sees it moving at the full speed of light. Stop and think about that for a second. Both of you measure the same beam of light at the same speed, but you're moving relative to each other at 200,000 kilometers per second. That's noticed more discrepancy. That's a fundamental violation of everything you thought you knew about how motion works. This isn't a theory. This has been measured. Albert Michelson and Edward Morley proved it in 1887. The speed of light is the same for all observers. Always. But how? How is that possible? Level 1. Time is not constant. Here's how Einstein solved it. He asked the question nobody else dared to ask. What if the speed of light isn't the thing that's changing? What if everything else is? If both observers measure light at the same speed, but they are moving relative to each other, then something else has to give. The math doesn't work otherwise. The numbers simply don't add up unless something you assumed was constant isn't. That something is time. Einstein showed that time passes at different rates depending on how fast you're moving. Not metaphorically, not philosophically. Literally, a clock on a spaceship ticking at 90% of light speed runs measurably slower than a clock on Earth. This has been tested. In 1971, Joseph Hurley and Richard Keating flew atomic clocks around the world on commercial jets. When they landed, those clocks had fallen behind the brown clocks by exactly the amount Einstein's equations predicted. Exactly. GPS satellites deal with this every single day. They orbit at 14,000 kilometers per hour fast, but nowhere near light speed. And even at that relatively modest velocity, their clocks drift 7 microseconds per day due to relativistic time dilation. If you didn't correct for it, your GPS would be off by 10 kilometers within 24 hours. Your phone would send you into a river. So time bends, time stretches. Time is not a fixed background drumbeat that the universe marches to. Time is personal. Your time depends on how you're moving. But wait, if time changes, what about distance? Level 2, space is not constant ether. Here's where it gets strange. It's not just time that changes, space changes too. As you accelerate toward light speed, the distance in front of you contracts. Not in an illusion, not as a visual effect. The action measured distance between you and your destination shrinks. At 99% of light speed, the distance to Alpha Centauri, which is 4.4 light years in Earth's frame, contracts to about 0.6 light years in yours. The space itself gets shorter. At 99.999% of light speed, that 4.4 light year gap crushes down to less than a light week. Now here's the thing that should bother you. From Earth's perspective, you're traveling for 4.4 years at near light speed. Normal? Expected. But from your perspective, the distance is so compressed that you cross it in days, maybe hours. Both are true, both are measured, both are real. There is no correct perspective. There is no God's eye view that shows what's really happening. Both frames of reference are equally valid. That's not a cop-out. That's the actual structure of space-time. Einstein didn't discover that you can't go faster than light. He discovered that the faster you go, the more the universe reshapes itself, time stretching, space compressing, so that light always passes you at exactly the same speed. The universe doesn't stop you, it rearranges itself. But that's still not the full story. Because if time and space are both flexible, then speed itself, distance divided by time, is built on two quantities that change depending on who's measuring. So what is speed really? Level 3, speed is not what you think nowhere at the core. Here's what Einstein actually showed with special relativity, and this is the part that should break your brain. You are always moving through space-time at the speed of light. Always. Right now, sitting in your chair, reading this, you are traveling through the dimension of time at 299,792,458 meters per second. That's your total velocity through space-time. It's fixed. It never changes. When you start moving through space, you don't add to that velocity, you redirect it. You take some of your motion through time and tilt it into motion through space. Think of it like a car on a perfectly flat field. The car always goes exactly 100 kilometers per hour. Always. You can't speed up. You can't slow down, but you can steer. When you point the car north, all 100 kilometers per hour go north and 0 go east. When you turn the wheel 45 degrees, some of your northward speed becomes eastward speed. Your total speed hasn't changed. You've just redistributed it. That's what happens when you accelerate through space. You're steering a fixed velocity through space-time. The more of your velocity you point through space, the less is left over for time. That's why time slows down when you move fast. You're literally using up your time velocity to pay for your space velocity. And here's the critical part. The speed of light, see, isn't the speed limit. It's your total budget. It's the magnitude of your velocity vector through space-time. Every particle, every person, every planet is hurtling through space-time at exactly c. No more, no less. You can't go faster than light through space because you can't exceed your total budget. And your total budget is light speed. That's not a law imposed on the universe from outside. That's the geometry of reality. Asking what happens when you go faster than light is like asking what's north of the North Pole. The question contains a misunderstanding about the shape of where you exist. In your normal experience of the world, speed is simple. You speed up, you slow down, you go faster than some things and slower than others. Time ticks along in the background, constant and reliable. Space sits there, fixed and measurable. Speed is just distance divided by time. Two solid things making one solid ratio. Except that's completely false. Time is not constant. Space is not fixed. Speed is not what you think it is. You have never been stationary in your life. Right now, you're hurtling through space-time at 299.792558 meters per second. You feel still because all of that motion is pointed through time. Every atom in your body is screaming through the dimension of time at light speed. That's why time passes for you. That's what the passage of time is. Your velocity through the time dimension. Let me prove it to you. Mere subatomic particles created when cosmic rays hit the upper atmosphere have a half-life of 2.2 microseconds. At the speed they travel, they should decay long before reaching the ground. They should never reach our detectors, but they do. Thousands of them, every minute slamming into the Earth's surface. Why? Because they're moving at 99.94% of light speed. Their time is dilated by a factor of 30. From their perspective, 2.2 microseconds is plenty of time. Because the distance to the ground has contracted to a fraction of what we measure. From our perspective, they live 30 times longer than they should. Same particles, same physics, two completely different experiences of space and time. Both are real, both measured. Think about what this means. There is no universal clock, no master timeline, no actual distance between 2 points that everyone agrees on. Space and time are personal. They depend on how you're moving. And speed, the most basic concept in physics, the thing you learned in middle school. Distance over time is built on two measurements that change depending on who's holding the ruler and the stopwatch. The speed of light isn't a limit on how fast you can go. It's a revelation that how fast you can go isn't a coherent question. You can redirect your motion from time into space. As you do, time slows, space contracts, and from your perspective, the universe compresses in front of you until destinations that are light years away are right there. You experience the trip in minutes, but everyone you left behind experiences years. The speed of light isn't a wall. It's the exchange rate between your time and everyone else's. This isn't speculation. This is measured to 11 decimal places. This is built into every GPS satellite orbiting above your head right now. And once you see this, you realize it connects to everything. Now here's what people miss when they learn just about the speed of light. This isn't an isolated quirk of physics. This is the geometry of existence. The same space-time structure that prevents you from exceeding light speed is also the reason gravity exists. Mass curves space-time. Objects don't fall, they follow straight lines through curved space-time. An apple doesn't get pulled to the ground. The ground accelerates up to meet it through warped geometry. Einstein showed this in general relativity, and it's the same geometric framework. Space-time isn't just the stage, it's the actor. The reason nuclear energy works. E equals m squared. That equation, the most famous equation in history, is a direct consequence of space-time geometry. Energy and mass are the same thing, converted at the exchange rate of c squared. When a uranium atom splits, a tiny amount of mass converts into energy at that ratio. The speed of light isn't just in the equation, it is the equation. It's the conversion factor between matter and energy. The reason you can't send information faster than light. Not because the universe is slow, but because cause and effect require it. If information could exceed c, effect could precede cause. You could receive a message before it was sent. Causality, the thing that makes the universe make sense. The thing that makes before and after meaningful depends on nothing exceeding that space-time budget. The reason time moves forward. The arrow of time, the asymmetry between past and future, is woven into the same space-time geometry. Light cones, the regions of space-time you can influence or be influenced by, are defined by c. Your entire causal future and causal past are shaped by the speed of light, the same constant, the same geometry, governing gravity, energy, causality, and the direction of time. What looks like a speed limit is actually the structural constant of reality, the ratio that defines how space relates to time, how mass relates to energy, how cause relates to effect. You're not separate from this. Every chemical reaction in your body, every nerve signal in your brain, every photon hitting your retina right now, all of it obeys this geometry. All of it moves through space-time at exactly c. You are a pattern of matter and energy navigating a four-dimensional geometric structure at the only speed anything ever moves. That's not a limitation. That's magnificent. So why can't anything go faster than light? Wrong question. You're always going at exactly light speed through space-time. Every particle, every photon, every atom in your body, all moving at c. The question isn't whether you can go faster. You can't go slower. You can't go faster. You are locked at exactly one speed through the fabric of reality. And all you can do is choose the direction more through space or more through time. Point all your motion through space. Time stops for you. You're a photon. You experience no time, no distance, no journey. For a photon, emission and absorption are the same event. The universe has zero width. Point all your motion through time. You're sitting still in space, aging at the maximum rate, experiencing time at its fullest flow. Everything in between is a trade. Space for time, time for space. Every journey, every orbit, every falling apple, just different angles through the same four-dimensional geometry. Einstein didn't discover a law, he discovered a shape. The shape of where we live. And understanding that shape didn't just rewrite physics, it redefined what it means to exist somewhere, to move, to age, to experience. 300 years ago, we thought space was a box and time was a river. Fixed, separate, absolute. Then one clerk in his Swiss patent office asked what would happen if you rode alongside a beam of light. And the answer tore apart everything we thought we knew and rebuilt it into something deeper, stranger, and more beautiful than Newton ever imagined. The fact that we can understand, the fact that a species of evolved primates on a small rocky planet can deduce the geometric structure of space-time from first principles and confirm it to 11 decimal places, that's not trivial. Mind. That's the most extraordinary thing about the universe. Not that it's vast, not that it's old, that it's comprehensible and that we bother to try. That's what the speed of light really is. Not a wall, not a law, not a cosmic speed sign telling you no. It's the shape of space-time itself. The ratio between space and time. The heartbeat of causality. You can redirect your motion however you like. You just can't outrun the geometry you're made of. Not a barrier, not a prohibition. A structure, not comfort, not simplicity. Truth. If this journey into the geometry of space-time changed how you understand motion, time, or your own place in the universe, subscribe and share this with someone who still thinks the speed of light is just a cosmic traffic law. What other simple facts do you think are hiding this kind of depth? Tell me in the comments. I'll dig into the best ones next.